Right, thanks, Zoom lady. So I'm going to show you the syllabus first. So I will throw the syllabus into the Discord as well a bit later. So I've done this in the previous class, but I think some of you are not here. So for the sake of you, I will repeat very quickly again. Okay. So the syllabus is very short, like surprisingly short. It only consists of a thing that is called general physics, which actually is a lot of stuff. And then we'll study a bit about heat, and then waves, electricity and magnets, and then atom physics or particle physics or nuclear physics, and that's it. Okay. So overall, generally speaking, what I'll probably do for our progress is I hope to finish both of this year in 2022. And then we'll do this in 2023. And then you will sit for your paper in October, November 2023. Okay. So for those friends who Malaysia one, we don't know what is ON. Okay. So for all Cambridge papers, they have 2 exam seasons. Okay. I'm not sure whether they told you this or not. One is May or June. They like to call this the summer paper lah, but I come from Malaysia, every day is summer, I don't know what taught me. The other one is October, November. This is the winter paper. So sometimes the paper code can be May, June, let's say May, June 2020, so it's May, June 20. So this front here is season. And then the back part here is year. Okay. Or sometimes if you look at certain textbooks or revision book, they will put summer 20. Okay, lor. So this is season, and the one at the back is year. Okay. So for Cambridge, there's 2 sitting. I think what normally happens for students from your center is that you will sit certain subject in May, June, and then you will sit other subject in October, November. Physics will be in October, November. I think bio is in May, June. Maybe you can go ask your bio teacher, or maybe your bio teacher will tell you. I don't know. All right. So with this in mind, we sort of like have slightly more than a year and a half, because now February already, and then October, so 4 months gone already. Okay, we have about a year and a half, okay, to cover the content. So I think 2022 hopefully can finish the first one, then 2023 we'll do this one. 3, 4, and 5 is shorter than 1 and 2. All right. So for Cambridge, right, you will sit for 3 papers. Okay, I think it's the same for all sciences. So if you're doing chemistry and bio as well, it should be the same format. So we are sitting for all the even papers, paper 2, paper 4, paper 6. Teacher, why? Because all Cambridge got 2 types of qualification. For IG, we have the core qualification, meaning if you can do this paper, you will get C or you will fail. So you know a certain subject in school, pass or fail only one, like I don't know. Last time for me it was Cerny, Pendidikan Jasmani, the PJK. So this is C or fail. But I think if you come from Catholic high school, everything also got grade, so I don't know. Nobody is going to take core here. Okay, nobody in Malaysia does it because we Asian lah. So this is for people who just want to pass high school. That's not us. We are doing the extended. So for the core paper, they are doing paper 1, paper 3, and paper 5 or 6, depending on the school. Okay, but this is not us. This is only in UK. So we're not in UK, just let it be. We are going to do the extended one because this is the minimum requirement for you to progress into pre-university or colleges. So the extended version, we will do paper 2, paper 4, and then paper 5 or paper 6. Nobody in Malaysia does paper 5. Teacher, what is paper 5? Paper 5 is you conduct the experiment, you write the lab report, you pass up. And that is just more work for you, more work for the schools. So even if you do private schools, no one does paper 5. Okay, there's too many requirements. The easier route is to do paper 6. So we'll be doing 2, paper 4, and paper 6. Okay. So then the next question would be, what is the syllabus, or rather, what is paper 2? Paper 2 is objective law, MCQ. Paper 4 is structure. If you come from the national school syllabus, which I think all of you are, let me know if you're not, if you are from an international school. I don't think anyone here is from international school, right? Okay, anyway. This one is structure, and this one is easier than, to be honest, easier than most SPM papers. Truth. Okay. So I'm going to throw the syllabus into the library sec. Oh, we got new friend. Syllabus. So the document that I'm referring to is this one. Okay. So right now, the paper that we are looking at, it's this one. So we have paper 1, which is 40 MCQ for 45 minutes. Paper 2, no, paper 3, paper 1, paper 2, 45 MCQ. No, sorry, we are doing 2 and 4. So 45 minutes, 40 MCQ. The theory paper for paper 4, the writing one, 1 hour, 15 minutes for short answer questions. Okay, and then the practical, we are doing 6. All right. So when it comes to preparing for the paper, if you come from SPM training or national school training, it should be okay, because you are already used to the fact that certain things have to be written in a certain way. But if you are a bit lost, okay, then it's important to know where to find the resources that you need. Okay, so I'm just going to put all the important information here, and then I'll print it out and throw into the Google Drive. Okay, so with time, we will be practicing across these 3 papers. Okay, so we will probably do some objective, then we'll do some structural question, and then if there's an important experiment that I would like to do, then we'll do here. If not, right, then if I don't practice any of this, then GG. Okay, so yeah, this is actually a very nice bonus paper because it's mainly calculation, which is okay. All right, so this one is experiment or lab report, but not really. All right, so that's it. Your syllabus, what you need to study, how you will be tested, when you will be tested, and what is in every paper, and the time duration, that kind of stuff lah. All right, so we will start, or actually we started a little bit already, from general physics. Okay, so general physics, right, is actually a very large and long chapter because of the way they arrange the syllabus now. I honestly don't know why, but it do be like that for them. So there are 8 subtopics. Okay, so I'm just going to list them down for you. General physics. And what are we studying? So this will be considered as an introduction to your syllabus as well. So in physics, right, when you say the word physics, what we are actually trying to do is we are trying to be able to observe surroundings. Okay, and then we want to try to be able to describe. But you see, physics, right, or sciences, when we describe something, or we can use different things to 形容 or describe something. So for example, I can use words, which is what I'm using now, no? English, Mandarin, Malay, whatever lah, I use words. But in physics, equally important is to use maths, which is equations and numbers. Okay, if the words and the equation, they have to work together, meaning they cannot contradict each other lah. All right, and then level up one more, we must describe this using graphs, by drawing proper graphs. So these are the skills that we will build up in physics. Can you use it elsewhere? Sure, you can use it to look at the COVID-19 numbers. You can use it to study whether the newspaper article makes sense or not based on the COVID data. So we learn physics not just because we want to be scientists, although that could be the case for you. It's also because we want to use this as an opportunity to level up our brain, like big brain. All right. So, but the thing is, when we observe the surrounding, this one can be as general as a moving object to as small as an atom or a nucleus or a proton to as big as the moon and the earth. So the scale does not matter. It's something that we can observe. Physics is quite different from chemistry and bio. Chemistry concerns itself with the change of the atoms and the molecules. How do atoms and molecules interact with each other? Under what condition do you produce those changes? And it's a bit like now I have a cup of coffee. How do you make coffee? What is inside the coffee? Bio concerns itself with, when I drink the coffee, how does the coffee interact with my brain? What is in my brain? Physics, physics is even more outside. How do I heat up the coffee? How do I boil water? How do I design the heater? So it's at different phase in time in your life, you will see that the three sciences will work together. They will have some intersection. But for physics, we want something that we can observe. Okay, it has to lead to something that we can observe. That's why this observation is oftentimes they try to emphasize this in paper 6. Try only lah, but I actually don't think it's really emphasized unless we really get to do the experiment. Okay, so for general physics, right, the first thing that we are going to observe, we're going to measure the most obvious things. Okay, so the first one about observation is things about length and time. So from something that is very, very big, like for example, where is the galaxy? We use length and time. To something that is very small, what is the size of a nucleus? Length and time. So our first concern is to look at the lengths and time of different things and how to measure it. And we will slowly level up from there. Okay. So this one is length and time, and it's a bit like physical quantities and measuring techniques. So we're going to measure a bunch of stuff. All right. Measuring stuff that we can observe. In physics, if I cannot measure, I don't want to study because I cannot give them a number. And if I cannot measure it, I cannot draw a graph. For example, the happiness of my student, the lameness of this meme, how to measure? Cannot measure one. So we must know how to measure general stuff. So I think I'll just paste in from your syllabus. Give me a sec. So if you look at what they want from you, right? Actually, pretty obvious one. We'll practice some today so that we get to focus on the mark scheme. But describe the use of ruler. Who don't know how to use ruler? And measuring cylinder to find length or volume. Can describe how to measure a variety of time interval using clock and digital timer. I think we're okay. Length and time. Determine an average value. Okay, also what? Okay, and also average value for small interval of time by measuring multiples. So for example, if I ask you to measure the time taken for the pendulum to oscillate, you don't only oscillate one time, maybe you oscillate 5 or 10 times. Okay, so this is the core component. And then the supplement component here, we are going to, okay, I'm going to move this a bit so I got a bit more space now. Move. Don't worry, I'll print it out for you. Okay, so we're just going to slowly build our understanding of general physics. So this is the extra one from the extended component. So we're going to later on focus on what it means to be scalar and vector. This part is new, maybe new to you, okay? And then we are going to look at different types of vectors and how to find by calculation or by graph when I have two vectors, and then how do I add them together? Okay, so basically the first part, right, 1.1, we want to, this is 1.1. We want to level up the tools, not just the measuring tools, like how you measure stuff, how to use ruler, how to find volume, how to find density. We also want to know how to write and describe the measured quantity properly. Because if you cannot write and describe it, and you measure already, let's say, for example, I ask you to measure the height of your friend, and then you go and say, teacher, 172. You know what I'm going to say, right? All teacher will say the same thing. 172 what? Chicken, pineapple, pizza, ang pao money. What 172? You need, right? The same idea. How do I write and describe the measured quantity properly? Okay. And how do I handle them? Okay. So we're going to start with this one first. Don't worry, we'll come back. We'll come back here and we just keep adding to general physics. Okay. So let's start from here. So 1.1. I'm going to call this physical quantities in measurement techniques. This is very heavily tested in paper 6 because you are doing labs, right? You measure stuff. I think I'm going to start off easy first. There's a line of my paper so I don't go all over the place. All right. Number 1. Things we use to measure length. Okay. So I think before we talk about length, it will be in your better interest if I just tell you what is a physical quantity. So physical quantities are things that can be measured using known methods. Meaning I already know, okay, maybe not you, but humankind already know how to measure. Methods or instrument. So for example, if it's like a mass of an object, we all know how to measure. We all know what 1 kg is. If you forget what 1 kg is, you can go to Paris and look at the 1 kg block. This is 1 kg. There's a standard 1 kg block lying somewhere in some museum. Okay, so whenever, if the whole world forgotten what is 1 kg, you can always go to that museum and go and find it. Nah, this one. See, this thing is 1 kg. Is display on, I don't know how to pronounce this because I am not a French dude, but yeah, when we want like quite that.
There's signs at the industry. Actually, I'm not French also, and I'm just reading literally just reading.
Okay, so it doesn't matter. It's in France one day lah. You mean you go traveling, you can go and see. Okay, thanks for trying. CSI. Okay, so it looks like this: a bell jar in a bell jar inside a bigger bell jar. Okay, sure. We need to protect this. Okay, so yep, can be measured and we already know what it is. Okay. Number 2, we start off with base SI units. You can see this like, oh, I start a show, Lord of the Rings or whatever. I introduce the main character to you now. Okay. So the base SI unit that we mainly focus on got length, got time, got mass. This is the top 3. So I'll write here physical quantity. And then physics people very lazy one. So if let's say I have to keep talking about length, then I'm going to use a symbol because ain't nobody got time to write LENGTH repeatedly. Okay, and then we have SI units for these things. And then I level up you some more measuring instrument. What instrument do we use to measure these things? Okay, good enough. Length. Normally the symbol we can use L la, L la, X la, Y la, A, B, P, Q, anything, etc., etc. Okay. SI unit here is meter. Okay, meter. M. And measuring instrument, this one got a few types. You got your meter rule, okay? And then we have your vernier caliper. And then we have your micrometer. You don't need to know how to read these things. You just need to know that they exist for your syllabus. But if you are doing SPM, you will need to know how to read it. So that means eventually you will learn. And by the time you don't know, you can also ask me, you can talk to me, okay? So time, the symbol is T. And then the unit is second. But again, the symbol for the unit is S because ain't nobody got time to write SECON. Physics people suck at drawing. So for this one, we can use timer, stopwatch, etc., etc. Different things are all can use. Draw a line to demarcate this. Okay, so these are the basic stuff. Cannot measure this or something is wrong with. If humanity, if let's say you go to some strange parallel universe, and then you talk to them about time, and they're like, "What is time?" And then you just, "Oh no, oh no." All right. So any scientific civilization should be able to reliably know how to measure these things, have everyone know what it means. Everyone knows what is time, 1 second, 1 hour. It's one of the first things you learn in primary school maths. Okay. Anyway, maths here, we normally use M. Sometimes I guess we use capital M, not fixed one. This one is kilogram though. This one will be in kg. Okay, so how do we measure this? Use a balance. Weighing balance. Balance is good enough, at least for IG. All right, still got, God. We got temperature. Every day we go and heat our forehead temperature. Sometimes we use T also, then confusion now, lor. Time is T, temperature also T. So you have to read the question carefully because physics sometimes use back the same symbol for the same stuff one. Okay. Sometimes we use theta. So this one, the SI unit is Kelvin. Then this would be Q. So this unit for temperature is uppercase K. Uppercase K. And then of course this one we'll use thermometer. The main thing is thermometer, but we have other stuff later in thermal physics we study. Okay, so we have length, time, mass, temperature. Am I missing something? Think about the list of topics that we have to study. We got electricity, right? So there's current of electricity. Symbol for this one is I. Teacher, where got I in current? What you want to use? C is the other ones are used for other stuff. So we use symbols sometimes that make sense, like for example, L for length, T for time, M for mass, and sometimes it doesn't make sense. Okay, there's probably some history around it, the symbol. But again, this is a French thing. So the conventional symbol for current is I. Again, I don't know how to pronounce. What is this? Intensity, I don't know, just current. Okay. From French. A bit of history there. Unit is ampere, symbol is A. Okay, of course, we're going to use an ammeter for this. So a lot of this actually got a lot of history. Just don't talk about it, but I just want you to know that it's not that we want to torture you, because sometimes the science was written in another language, then we translate. Some of it is lost in translation. 1, 2, 3, 4, 5. Okay, 2 more. These are the common ones. Okay, so we will learn about these 3 in general physics. Of course, not just these 3, but everything will be built from these 3. Okay, we'll learn about temperature in thermal physics. And then when we learn waves, we will go back to this one. Wave will travel, sound wave got speed waves. And then current of electricity is your atom. This one would be electricity and magnetism. That typing. Electricity and magnetism. And then nuclear physics would be back to this one. So you can see how important the first three is, because nuclear physics, we're going back to the atom. Nuclear. And because just now I was looking at the old syllabus, I've forgotten your exam is later. So you have a new syllabus. I'm gonna this is the new one. Look at this, we have space physics. So cool. Guys, we're gonna learn something about space. Big Bang Theory. Expansion of the universe. Yay. Okay, anyway, I'm gonna go back here. Space physics will probably be a combination of general physics and waves. Here will be space. So we level up. Actually, it's all three. We level up. You can go to look at outer space. Also, maybe a little bit of thermal physics, depending on what is in your syllabus. Yeah. So you can see, right, in the very first chapter, very first subtopic, we already introduced to you all the cast of character. And I think if you do normal science in your high school, you also will see all this already. And then you wonder, why must I do this? This is why, no? Because this is actually the building block, okay? And with space, right, we need to add something as well, which is called luminous intensity. Basically, this is how bright is the star when we stare at it. So normally it's L. They won't ask you to list down the units. I don't know. It's just for you to learn. So we need to add this for the waves. For the space physics. Oh, such a cute name. Not astrophysics, but space physics. We can go to space now. Okay, so the unit for this one is candle. Candela. Candela. CV. How to measure this? Not as straightforward as take a meter and measure lah. Okay, so this one need to study some laws one. But mainly we look at the wavelength of the light from stars, distant stars or galaxies. Okay. There's 7. So I will talk about this last 2 is not that important. The other one is called the mole. So if you learn chemistry, you would have known the mole, the symbol is M. And the mole here, just in case you don't know what it is the number of particles. It's about number of particles. So this one got no unit one, or the unit is mole. And we don't really measure it, we calculate. So this 2 is not as straightforward. But yeah. Okay, that's all for physical quantities. And the reason why we want to list down is so that we get the lay of the land, or rather get an overview about the physics that we're supposed to study. And we're now going to do some questions, because I don't think you need me to show you how a meter rule looks like, right? You're okay. All right, so depending on your, I don't know how you are studying now, you fully digital, half hard copy kind of person, but nah. So inside the Google Drive on the classroom, I have uploaded the topical past year paper, and it's a lot of pages, like freaking 798 and 1113 pages. So everything is already listed down with the answer at the back. Okay, so I don't feel like you should print 1113 pages, but I leave it to you. Today we are in chapter 1. Okay. So I will do questions from here. All right. And the reason is because past year questions, man. Past year questions are OP.
Teacher, why
Hmm.
is chapter 2 so OP long?
Because chapter 2, actually general physics is chapter 1 to 4.
But chapter 1 only 32 pages. Chapter 2, what the heck? What is going on? Like 100 leh.
Aya, it's a popular chapter, my friend. We study moving stuff. All right, we're gonna look at chapter 1 first, the objective questions. And we will try to go through all the instruments on the list. And by list, I mean ruler, length, volume, clock, and period. Okay, we'll go through that. Then you can see how whether the question is easy or not easy now. You see, Yuri already did a lot of work. Yuri, you do until which page now?
Oh, I didn't take out right now.
Ayo. Okay, then I randomly choose paiseh if you do already. Okay. All right, so we're gonna look at the length first, I guess. Length. Okay. Page 14, or you can just stare at the screen. Click here, click there. Maybe you're just joining on one device. Okay, so page 14. This is paper 1, so this is the core paper, which is supposed to be for everyone. Later, I'll give you an extended paper question. So here we have 4 identical spheres placed between 2 wooden blocks and a ruler. What is the diameter of one sphere? It's a primary school question. Dot, 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 4. Dot, 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 12. So here to here is 8. Don't forget to steal the unit cm. So the diameter will be 8, and then I got 1, 2, 3, 4. Easy. So length measurement, they're not hard. Okay, they're all fairly doable. All right. So sometimes we want to measure length because we want to calculate other quantities. You can find this question in page 17. Maybe I just leave it here lah. Okay lah, I let you try lah. Extended one, this one. Empty rectangular box, and I fill it with liquid. The box has a mass of 60 grams when empty. When filled with liquid, the total mass of the box and the liquid is 300 grams. Density of liquid is 1.2 grams per cm cube. What is the volume of the liquid in the box? Let me know your answers in the chat. And also, so I know that you are still alive. You okay? I want to go and find some. Thanks, Jeremy and Charlene. I see your hands. Okay, thanks. Everyone have already answered. So the answer is B. Okay, so very quickly, 60 gram, 300 gram. We know that the density of liquid is 1.2 gram per cm cube. So we start with density is mass per volume. Okay, so 1.2. The mass is 300 minus 60 because the box is 60. Okay, this is already gram. So we can maintain this one as gram. Okay, and then the volume is, I guess they just want to be. So 240 or 1.2. Yep, it looks like 200 to me too. Okay, so it's generally fairly doable one. Even the so-called extended, it's not, is, to be honest, it's nothing. Okay, should not be that much. Okay, so let's do a slightly different one regarding density before we move on to look at volume of irregular shapes. Okay, so very similar leh. That's why we do past year, because 他们来来去去 ask the same thing. But now they're asking the density of the liquid. So you're like, no, this is the same calculation. What? Density is mass over volume. By the way, my symbol for density, symbol for density is supposed to be this. I make bigger. This. 但是 if I write like that, 我写下 will look like P1. Or I write, then it will look like E. I've done this before in high school, and then my whole question gone. So I have learned to write density with a fancy calligraphy, okay? But the density symbol is this one. We pronounce this as rho.
Teacher, this row, when you draw row as a P with a fancy little tail, accept that.
Can I say? Because my school teacher also write like that. And then I'm like, 不准的 must be like this, because you know Chinese school ma, every goal also got meaning one. And then I can't write different GG. Okay, I go back to writing like that. Or you write it differently so you know it's not P. Just write it differently. Okay? Because later you have equation like pressure is H rho G. And then 你左边一个 P, 右边一个 P, the PP. Okay. All right, anyway, you are looking for the density, so 600 minus 120 divided by the volume. Ah, they even give you the volume. Chef kids. So I think this one is C. Is it C? C, right? Is C? No, it's not C. It's less than C. So B. So the mass difference is yeah. Okay, like that one. Okay, like we level up some more. One of just water in container not enough. We're now going to throw stuff inside. Like that. Okay. Page 21. The student measures the volume of a cork. You know what is a cork? The wine. I need to change my keyboard. This is a cork. 会浮的, it will float because it's very it's not very dense. He put some water in the measuring cylinder and one glass ball. He put the cork and then a second identical glass ball. You know what's the purpose of the glass ball? Why? Why so kacau? Why cannot put the cork inside only? Why so kacau?
To prevent the cork from floating.
Very nice. Thank you. So to prevent cork from floating. So they gave you all three water levels. And what's the volume of the cork? What's the volume of the cork? I guess you can type the number in the chat. It's 50, 60, 100. What is the volume of the cork? I can scroll down a bit now. 30, 40, 50, 100. 100. I'm just gonna veto out 100. Yes, you're all right. It's A. So 就是这样啦. It's not that hard. Okay. So when it comes to, so we measure all of this already. Now we're going to try and see if we have any time question. We're going to measure time intervals. Okay. But maybe I'll give you something a little bit more interesting. Or maybe something that you are not used to.
Teacher got number.
What number here? Cannot hear you. Are you talking?
12.
Number 12. Okay, I'll return back to number 12 after we do this one.
Never.
Okay, so this one is in page 22, right? And it says that the student investigates the rate of flow of oil. So whenever you see this word rate, in Malay, it means kadar. Or basically changes, whatever, anything can change, okay? Changes per unit time. So if you check the units here in the final answer, is cm cube per second. Cm cube per second. That means it is change in volume because of the cm cube divide by time. So in this question, we are dropping oil into the measuring cylinder. So the initial measurement here looks like 2, 4, 6, 8, 10. Okay, so this one looks like 22. And this one looks like 3, 4, 6, 8, 70 cm cube after 1 minute. So whenever you see rate, it's changes per unit time, and then you need to read the question to see what is changing over time. And in this case, it is the volume of oil. Okay, different question, different stuff. So now, if I want to find the change in volume, I will take 70 minus 22 divided by 1 minute. Okay, I double check first. Here is second. So if it's minute, then you can put 1. So it can be cm cube per minute. But if they say per second, then we divide by 60. So this one. My calculator entah hilang ke mana. So I will use my desktop calculator. I got one is people, where is it? So in it's a bit late, because I'm going to do maths, divide by 60. 4 over 5, or you press this SD 0.8. cm cube per second, because you see this unit is cm cube and this unit is second. The answer is clear. I think it's pretty straightforward. Now we're going to look at 12. Since we point out 12. What is nice about 12? Let's see. Wow. Okay, good one. Good choice. So if we reverse back to 12, which is page 6. So we have a cyclist round the track 3 times. Okay, very free. Her friend uses a stopwatch to record the time at the start of the ride. Okay, sure. And after one circuit, That means one round. And then 3 rounds. Okay. What is the average time for her to travel 1 round? Obviously, because you are human, you can't be sure every time you travel is the exact same time now, right? So, what do you think? All like next question, just like not too complicated, hopefully not too complicated. But if you want explanation or more detailed one, just disturb me lah, disturb me a bit, I'll explain. So 这个人踩脚车 first lap means first cycle. 180 minus 6 is 174 seconds. Second lap plus third lap is 600 minus 180. So here to here is 174 seconds, then here to here. So it's 3 circuits, so it's 3 laps. So between lap is lap 2 plus lap 3. This is 420, right? Not very good in. Okay, like that. So hence the total time, which is all 3 laps, is 174 plus 420. And then you want 1 circuit. So if I want average, will be 174 plus 420 divided by 3. Let me put here. 174 plus 420 divided by 3. So 198. Okay. But this kind of timing questions are not necessarily too complicated, I don't think. It's just that
okay.
Why,
Teacher, I just straight up 600 minus 6 divide 3 and get 198 also there.
See, you faster. Very good. Waiting for someone to tell me. Why you so why need so hard? Just 600 minus 6 lor. Because here to here is 3 lap liao ma. 这样老师 they give us this for what? Why do you think they give us this?
Confusing, bamboozle.
To bamboozle
confuse
you.
us, to bamboozle us, to make us think this is 4 laps. And yeah, this is like very useless, like one of the calculators in the calculator covers. Yeah, calculator covers. Some people, there's this one calculator that can make music one, and then some people use these calculators, a few of them, to make music, but one of them they just leave it just there.
Okay. Sure. Please don't bring a musical calculator into the exam. Anyway, yeah, so it's not, at least I hope it's not that hard. You can tell, right? Of course, every question is going to be different, but I'm pretty sure you can read it and, infer whatever information you need to, that is necessary. Okay, so this is basically how paper 1 will look like for this subtopic. Okay, next, we're going to look at paper 2. Sorry, I keep saying paper 1 and 2 because my brain is in A levels. So if you don't know me, I teach A levels from Monday to Saturday until I see you. Okay. So objective is paper 2. All right. Then now we're going to look at paper 4, or the structured questions. All over the place. All right, let's look at something a bit more recent. This is to see whether the recent question is harder or maybe who knows. Okay, so oftentimes this kind of chapter, right, they will ask together with other subtopics. So maybe there will be not that many questions that you can do. But let's look at page 23. I'm still going to copy for you, okay? I think this one all is bonus. It's also an extended group. Bonus. Bonus. Okay. Yep. Finish. So page 15. This one is page 24. So here is a hollow metal cylinder containing air floating in the sea. Very nice. So the part that is floating in the sea is 1.2. The part of the whole cylinder is 1.8. The density of the metal used to make the cylinder is more than the density of seawater. But then the cylinders still float wall. Why?
It has a hole in it.
How does the hole affect whether it floats or not?
It reduces the volume.
Reduces the volume. Reduces the volume. What do you mean by reduces the
I
volume?
don't know because if this was a solid, if this cylinder doesn't have a hole in it, the volume would definitely be more than the one that has hole in it.
The volume of the one that has hole in it will be more.
No,
what you're
it's
saying?
the one with hole will be less.
The one that has the with hole would be less. Ooh. Okay, but you see, if I consider this this whole thing as one, the whole thing, including the air and everything, and I want to find the density, I have to use the mass of metal, whatever the metal is, plus the mass of air, which is very small or missing, divide by the volume, correct? That is the density of the combined density. So can I say that the combined density is less than seawater because of the air, right? So the combined density of metal and air that makes up the cylinder is less than the density of seawater. So it's still less dense, but we cannot just look at the metal. So if I remove all the air and I compress the metal into like a little ball, the metal will sink, definitely. Okay. So here they are telling you that the cylinder has a length of 1.8 meter and it floats with 1.2 meters submerged in the sea. The bottom of the cylinder has an area of this much. Okay, density of seawater is 1020. Calculate the force exerted the bottom of the cylinder. New friend, new physical quantity, force. So we will probably properly be introduced to this a bit later. Okay, but this force is called buoyant force. I'm not sure what it is in Mandarin, but it is the force when you go swimming, the water is pushing you up. This is the force of the, this is the force mainly due to pressure difference between the top and bottom parts of the cylinder. So we go back to this one. So I need to borrow a bit of your year 8 knowledge and see whether you still remember or not. last year's graph. Okay, let's consider pressure. Let's look at the bottom. If you're chilling at the bottom of the river, do you notice that your pressure is quite high? Those of you who listen to people go snorkeling, you have this whole layer of water, right? This whole layer of water just squishing down on you. Wow, and pressure. You have 1.2 meter of water. So at this point here, there is the pressure, and pressure acts in all directions. Okay, so the meaningful pressure is not the one that is on top, it's the one that is below, that is pressing down. So pressure, number one, the concept that we need to remember is that fluid pressure, so fluid here is for gas and liquid. Anything that flows is fluid. Acts in all directions. You want an example of this? You go and make a water balloon, and then you poke hole. The water spray out in all directions, right? Correct. If you fill the water balloon with sand, and then you poke hole, the sand will only come out from this part. They won't come out from here. So pressure acts in all directions. Okay. Number two, pressure at the bottom, as I call this P2, so the pressure here is P2, is larger than on the top, which is P1. Teacher, where is P1? P1 is up here. Let me highlight. P1 is here. I care about the part that is inside water. Okay. So there is actually some water pressure pressing down here. But actually, the pressure here is atmosphere. P1. That's why you have buoyant force. P2 is bigger than P. The third thing you should recall is the definition of pressure. How do we calculate pressure? We take force divided by area. So the question is asking us, what is the force? So if you look at this one, P2 is bigger than P1. So it is the pressure difference that helps generate the upthrust force. This force is upthrust. So you imagine bottom, the water pressure is pushing larger than on top, the air pressure. So you will get a resultant force in this direction. Now this is upthrust. Okay, so we're going to use this. This is the main relationship that we will use. Pressure difference is force per unit area. And of course, it's the pressure difference between the top and the bottom. Okay. So right now, P1 here, there is nothing pressing on here except atmosphere. And P2 is actually the pressure of the water plus, don't forget, we are all inside atmosphere. I don't care whether you're under the sea, on top of the sea, wherever, you still have atmosphere. So atmosphere 是到处都有，没有的话 you cannot survive. You will explode. You cannot breathe. Okay? So I'm just gonna, don't need this. I need space. Just gonna take away this one. All right. So I know pressure difference is equal to force over area. I write first. So I can get my first mark. So I don't know whether I can do the question, so might as well I can get my first mark. To find the pressure difference, I will take P2 minus P1. And then, you know, physics people lazy one, I substitute symbol, okay? Force over area. We are looking for force, okay? So repeat the question one was to find force now here. Force, what force? All right. Okay, so P2 is the pressure of water minus, oh sorry, plus atmosphere first, plus pressure of atmosphere. I put ATM. This is P2. Minus P1. P1 is only atmosphere. So I decay, if you notice or not, but hey, the pressure of atmosphere, no. Plus minus, no more. So now you have force over area. So pressure of water is force over area. Okay. But to find the pressure of water, okay, maybe a little bit information overload if you don't know this, but the pressure of water can be calculated using the equation depth times density times gravitational acceleration. Okay, so later on, I'll prove to you lah, but finish by 6:30. We are going to borrow this equation also from your year 8, year 9. Okay, so at first, right, when you do physics, it's like very scary. Your equation everywhere because you are getting to know more and more new physical quantities. So previously, we did length, we did time, we did density. Now we level up, we want to include force and pressure. There will be more equations. So what we have now, pressure difference is force per unit area, but we also know pressure of water is H rho G, where the H is this. So I'm going to put H rho G here. And then I'll multiply by A lah. Just bring the A up. Equal to F. So the depth of the water is 1.2. The density of seawater is 0.8. Gravity is 10. So Earth's gravity is always 10. 10 Newton for every kilogram. So if you're 1 kg, gravity will pull you down by 10 Newton. And this value, they expect you to know lah, right? Or to be familiar with it. Area is, wait, my density is not 0.8. What density is 1020. My area is 0.80. Good thing everybody is SI. If not SI, you have to convert because you want to write the final answer as Newton. So we gotta press, my friend, the calculator again. 1.2 times 1020 10. Okay. So this is 9792. In Cambridge, right, you can write to 2SF. 2 significant figures. So the calculation slowly will begin to level up. So physics is not just describing what is going on. See what I do here in the purple? It's also being able to represent that understanding into equations. And with practice, hopefully it is like a second nature thing to do. Okay. But we will go through pressure again. Don't worry, you'll see it again in your syllabus if you've forgotten everything. Teacher, what is line? Kilo? It's okay. All right. I want to give you some homework to do that doesn't look like this. Don't worry. And this thing is 4 marks anyway. That's why the calculation is a bit long. Okay. So I believe, okay, I can finish the question for you. If I see H rho G like this, you get 1 mark. If pressure is force per unit area, you get 1 mark. Your final answer is 1 mark. And then if there
What's
is
rho again?
density,
Rho density.
H is depth,
Yeah.
Rho is density of the water that you are in. Doesn't have to be water lah, can be oil, can be anything. And this is G. G is just 10. Gravitational
Okay.
acceleration.
Thanks.
Okay. All right, then the final mark here is the substitution. Okay. Well, I'm going to give you homework. And let me show you how to do it. Or rather, basically, how to submit it. I got too many windows, man. See? Hang on. Let me find what I am looking for. It's not this one. Wait, I need to look at the clothes. Look at my bank account. Aha, okay, right. Okay, I'm going to share a link to this PDF later. Okay, I want you to just do question 1. Just question 1. If you cannot do this last part, you can skip it. Focus on question 1.
Question 1. What? From
One
where?
whole question. So I will put the link again in Discord, but right now I will just throw into the chat lah, so that you can open it now. Okay, so you just need to follow the instruction. Teacher, they give me this paper, I put ruler here to measure. Yes. This one is like SPM paper 3. You put the ruler there to measure. And since, you know, some of us
Teacher, I'm
yes.
doing it online. What do I do?
You're doing it online, good question. So if you do this online, wait, I will tell you the length. I'll tell you the length. No sweat. Paper 6-1. Okay, so if you're doing it at home, the length is 22 mm. 22 mm. You're right, 22 mm. I will type again and remind you lah. So he measures the new length of the spring. You see, 量都量给你了，写了打下去。I think you can do this. You can use the equation. You can continue. Try, this is just calculation. So when you finish, you have a few choices. You can obviously print the whole thing out and hand do, sure, if you've got printer. If it's not too much of a hassle for you, that will be the first 4 pages. Okay, no, don't need page 1 lah, 2, 3, and 4. Okay, you could type out the answer if you want to, or you could just take out a piece of paper, write, and take a photo. Okay, so I'm gonna create a channel here.
Teacher, didn't you make a channel already called what links?
Yeah, I'll throw today's work into the channel. Let me arrange later. So homework submission. So what you can do is you can do like what your friends have done here. They can take photo because they printed out. Or you can just write on paper and then take a photo. If it's got shadow, all that, it's fine. See, not all got shadow, it's okay. Can do 可以了。Dump inside. Yeah. Okay. No need to click, no need to upload, just throw inside. However you want to do it, up to you. If you're writing a writing tablet, then you can do it easier lah. Because writing tablet, your submission would probably look like this. This one is my writing tablet. So when I click, I can look at the whole thing. If you use a writing tablet, you can print screen.
Teacher. Teacher.
Yes.
I think everyone will see what you submit there.
Oh, would you prefer to not let everyone see what you submit?
Yeah.
Okay, if that's the case, I will
Privacy is privacy is important and plagiarism is a crime.
Okay, sure. Then I will create a private channel with just you lah. I start with you first. Okay, I will adjust lah, don't worry. So then you will see your name. Ken, then you throw inside lah. Cool.
Okay.
Okay, I want to let you go first because like dinner time. Yeah. So just do question 1. All right, just do question 1. Just get a feel about how the different paper is like. So you can see paper 4 is the harder paper. Paper 1 is okay. Paper 6, I hope you also see that it's okay. If not, we can always discuss next week. All right. So stay safe, stay sane. Any question? Nah, you come here and chat with me lah. Okay, ask question. All right.
Wait,
don't
do
be
the
shy.
whole paper 1.
Do the whole question 1.
Oh, okay.
Just question 1. Okay, thank you.
Gosh, you want to overwork yourself, meh?
You want to do, I'm not going to stop you. Just do. All right, that's it. I will see you. If there's any other thing, I will just put it inside the class recording channel lah. Okay lah.
Wait, there's
Well,
only one question.
yes, there's only one question for
So
now.
do the whole paper.
There's only one question there.
Okay.
Are we looking at the same paper?
Yeah, there's.
I think there's 3, right?
Oh, okay.
Is it the 3? Yeah, there's definitely more than 1. So just do question 1.
One question is like 4 pages.
Yes, the question is 4 pages. So that's why do 1. No need to do the whole thing. It shouldn't take you more than 20 minutes to half an hour. It shouldn't. It's just to see whether you can comprehend the question. The rest no need to do first. We will slowly level up so that we can do the other ones. But hey, this is just length measurement, which should be okay. And time measurement. All right, that's it. Any question, you just ask me and then I'll update this stuff and maybe do some organizing. I'll create a private channel for you. Don't go first, I want to take attendance. Just tough life. Okay, that's all. Take care, stay safe.
Yeah.
Bye-bye, Jeremy, Charlene, Yuri.
Bye-bye.
Okay.
Okay.